Now, waves can occur in different numbers of dimensions, right? We can look at waves in 1 dimension, which are the easiest to examine. We can look at waves in 2 dimensions, or even in 3 dimensions. And all of these waves will look a bit different. A wave in 1 dimension might be a wave on a string, for example, in a violin. A wave in 2 dimensions might be ripples on a pond. We can see that they don't just spread out in one direction, they spread out all across the surface of the pond. So that means that they form a circle away from the original disturbance. So if a 2-dimensional wave looks like a circle, then what might a 3-dimensional wave look like? Well, you've guessed it, a sphere. So if we look at something emitting sound or light, like the sun, the light will spread out in 3 different directions. Make sense? Sound works as well. If something makes a noise, then no matter where we're standing around it, we'll hear that noise. So that means that the wave is spreading out in all different directions. And so it's a 3-dimensional wave. In how many dimensions do the following waves travel? Part A, the light from a candle. Now, when we light a candle, can we see it from only one direction? Or can we see it from just a single plane? Or can we see it from all directions? The answer, of course, is that we can see the light from every single direction, and therefore, it's a 3-dimensional wave. Part B, how about a wave traveling along a stretched out spring? Now, in this case, the wave can only travel in one direction, along the spring, and so, it's a 1-dimensional wave. Finally, what about a shockwave from an explosion? In this case, just like for part A, we can feel the shockwave from any direction, whether we're in one direction or another direction or even above it. So, if it spreads out in all directions, it must be a 3-dimensional wave.